Let's now look at taking the binomial and its expansion and integrating both sides with respect to x. So again, I'll just pause the video and complete it and then talk about it. Okay, so as you can see, we are just following the normal integration rules where we're going to add 1 to the index for x and divide by the new index. So we will get nc naught x, then add 1 to the index, divide by the new index, we'll have nc1 on 2 x squared, plus doing that all the way through, and we know that there's a possibility of the constant, which we just place at the front so that we don't forget it. To find the value of the constant, substitute x is equal to 0. We know that when x is equal to 0, then we'll have 1 over n plus 1 will be our constant, plus 0, blah, blah. So our constant is equal to 1 on n, and our integrated expression becomes 1 plus x to the n plus 1 over n plus 1 is our constant, plus nc naught x, nc1 x squared on 2, and so on. Now, I think the most common feature of that the result of integrating is the introduction of these fractions. We haven't come across anything like that before, and so that stands out as a very prominent feature. Some examples of other sorts of identities that can be formed. If we were to sub x is equal to minus 1 into this, then it ends up looking like 0, x is minus 1, is equal to 1 on n plus 1. We're getting this alternating signs on our expansion. And again, there's the presence of the fractions. So really all I can say about identities that are a result of a binomial being integrated is that you'll see the occurrence of fractions. And clearly, when there is no x term in the identity, then it's also been subject to a substitution, which should be pretty obvious from one of either the right hand or the left hand side involving a constant.